Hello, thank you for tuning in to my resource presentation. My name is Sonia Stitt. I currently work in a government primary educational context. I am responsible for teaching a variety of subjects including English, Maths, Science and the Arts to Year 5 students, as well as the new Digital Technologies curriculum to Year 3s. STEM is in a developmental phase at my current school, with a push to have a STEM leader in each year level who will disseminate STEM knowledge, understanding and practices to all the teachers on their year level. This setup was a natural development that occurred when we were loaned Pepper, the AI robot, for a month in Term 1. I became lead on the project and taught myself to use the choreographed program, which I then taught to one teacher on each year level. They then developed a lesson which they led with each class on their respective year levels. From this led to the development of a STEM team, of which I have been instrumental. I have contributed to the whole school STEM plan, devised the Digital Technologies Implementation Plan. I am the Queensland Tech Schools Ambassador. I design and disseminate a school-wide technology newsletter. I assisted with forming a local technology cluster for teachers, as well as designing and proposing the implementation of transdisciplinary STEM units, which are now in development phase. STEM has been my passion for many years, and I am very excited about the journey I am taking at my school. My first artifact is a short activity I have my Year 5 students complete as part of the Earth and Space Science Unit, covering the Australian Curriculum Content Descriptor ACSSU 078. The Earth is part of a system of planets orbiting around a star, the Sun. The relevant part of the unit is investigating how shadows form and how they can change during the day and during the year. The process of the activity is to give each student 3 pipe cleaners and an A4 sheet of paper. Students are given 5 to 10 minutes to construct a humanoid shape that can stand upright on its own and is no larger than the A4 sheet of paper. Once the students have constructed their humanoid figures, we take them outside and place them on a line that we have drawn at the bottom of our A4 paper. The students then trace the shadow created on the paper by the sun. At different time segments throughout the day, students trace the shadow again and then compare results. This activity incorporates design, measurement, and scientific elements. It's hands-on, and the students are always very engaged. It was interesting to me as a teacher to see which students could easily conceptualize the figure and those who couldn't. One of the areas for national action, as outlined in the National STEM School Education Strategy, is increasing student STEM ability, engagement, participation, and aspiration. Students will be exposed to mathematical literacy throughout this science activity. With numeracy and problem solving being a school-wide priority in my educational context, this activity fits mandated curriculum requirements and also stimulates student engagement as well as creative and critical thinking through its hands-on application. Primary years is critical for student engagement and application in STEM, so allowing for STEM activities in the current curriculum in my classroom context is significantly important and will be instrumental in further STEM curriculum planning to allow for student engagement. My second artifact is a digital technology implementation plan. As an ambassador for Queensland Tech Schools, I was required to devise a plan of how digital, and by default design, technologies will be implemented into our school. The plan outlines the timeline for digital technology implementation, current staff capabilities, and future development. It highlights our usage of a STEM team and 2 technology leaders. The plan takes into account any relevant alignment with other curriculum areas. This artifact meets the second area for national action as outlined in the National STEM Schools Education Strategy, increasing teacher capacity and STEM teacher quality. By planning how digital technology will be implemented in my current context, we can plan for boosting teacher confidence and capacity and improve teacher readiness in STEM through enhancing teacher preparation. Resultant of my writing of the Digital Technology Implementation Plan, regular staff professional development has been implemented, along with attending a local cluster of like teachers and the securing of the University of Adelaide's Computer Science Education Research Group using my school as a host for a regional massive online open course, or MOOC, professional development opportunity. My third artifact is a STEM unit plan that I designed. When I was designing my school technology plan, I realised it was a great opportunity to see how transdisciplinary STEM units could fit into our current curriculum. Our whole school planning was based on subject area rather than year level, so the first step to writing the unit was collating all the Australian curriculum content descriptors being taught and assessed across each of the year levels. From there, I looked at how we could combine related content descriptors with current units, then seeing how our current resources could contribute to the design technology, or engineering, and digital technology elements. Once the unit was completed, it was presented to upper management of my school and a plan drawn up for a trial implementation. Again, very exciting times. The Australian Academy of Technological Science and Engineering promote the teaching of STEM as a vital priority for improving educational outcomes in Australia. One of their visions is enhanced fundamental STEM teaching in primary schools to capture the imagination of students and to inspire their interest to continue STEM subjects through to secondary and beyond. By designing detailed, thoughtful, sequential planning for STEM units, students will be given the opportunity to apply higher order thinking skills along with critical and creative thinking to solve real-world applicable problems and demonstrate their understandings in the STEM disciplines. My fourth artifact is a code club I am jointly running. A year ago, a fellow teacher and myself were on a PD that initiated us into the world of coding and digital technologies. We saw a discrepancy of what we were capable of offering and what we were actually offering at our school. Within a matter of weeks, we had established a lunchtime code club which runs twice a week for years 3 to 6 students. We initially began with year 5 and 6 because they don't get the privilege of learning the new digital technologies curriculum in class time. We had to extend it to years 3 and 4 because we had an overwhelming interest from our younger students. We have run through a fairly in-depth Scratch program of learning with the students, where they have been designing different types of games and presentations. We have also had 6 students enter an ACER video game design competition using Scratch. We have really highlighted with students the need to debug their algorithms rather than give up, and the need for collaborative work. This year we have advanced the students with the use of Makey design technology and Sphero robots. The younger students have also been using Code and Go mice. The majority of our Code Club participants have been completing coding in their own time, both online and with robotics. In my current context, the new digital technologies curriculum is only offered to years 1 to 4 students. As a result, there is a deficit where years 5 and 6 students are void of learning any digital technologies. Through our Lunchtime Code Club, we are giving students the opportunity to learn code, which engages students in developing their skills in critical thinking, creativity, collaboration, and innovation. Coding is the literacy of the future and is vital for every student to learn. In my current educational context, I have been assisting with the development of STEM and digital technologies within our curriculum and school community. As it's something that hasn't been done in such a defined manner at my school before, it needs to be well planned. To maintain quality assurance and outcome standards, it must be done as a step-by-step, unhurried process. The ultimate plan is to have teachers actively looking for ways to incorporate STEM activities into their units, coinciding with the National STEM School Education Plan, for there to be mandated transdisciplinary STEM units across all year levels, led by a STEM coach, and to have full implementation of the digital technologies curriculum. I strongly believe that students need to be given an opportunity to participate in transdisciplinary STEM units that allow them to develop their critical, creative, and collaborative skills and be active 21st century thinkers and digital citizens. I hope I have managed to highlight some minor and major STEM artifacts to you, carrying you on a succinct journey through my current STEM context. Thank you very much for your time.